In this lesson, we'll outline techniques that can be used for troubleshooting VoIP systems with interoperability issues. We'll define the network setups that are required to do effective troubleshooting. We'll address troubleshooting mechanisms available in third-party soft phones. We'll make the introduction of arguably the most powerful VoIP troubleshooting tool, Wireshark. And we will outline the process of decoding a Wireshark trace. As you install more and more VoIP endpoints, device interoperability issues are bound to occur. The ability to troubleshoot and overcome these issues is imperative to facilitating a successful installation. But if you are experiencing VoIP problems, where should you start? The majority of issues found in VoIP systems are a direct result of human error. Username and passwords can be misaligned. Steps in a setup can inadvertently be missed. The first troubleshooting step that should always be taken is verifying the basics. No installation of a VoIP endpoint can be done without the involvement of a VoIP administrator configuring the proxy server. Start by seeking out this person to walk through the initial steps again. Verify that the network parameters in place on the endpoint are the ones expected for a typical phone on the network. Revisit all endpoint credentials on both sides of the setup to ensure everything matches. BIAMP's support site, Cornerstone, has a wealth of information regarding specific issues with our products and different manufacturers' VoIP systems. Run a quick search of the site to see if a resolution has already been documented. These basic steps will help identify the problem and allow you to move forward with the endpoint setup. But what happens when these steps don't resolve the problem? In this training module, we will take you further into troubleshooting with a large focus on the packet capture program Wireshark. At the end of this module, you should at minimum be able to set up and run a successful trace of a VoIP problem. You may even be able to identify issues within the trace, but if not, the next step would be to get in contact with BIAMP technical support with a copy of the trace and the relevant configuration file. It's time to make the introduction of a powerful network monitoring tool and an even more powerful VoIP monitoring tool, Wireshark. Wireshark is a free software platform that allows a user an in-depth analysis of network packets. Packets sent on a network are converted into a readable format displayed on a GUI. Traffic can be picked apart, and packets can be analyzed for problems. Wireshark offers many built-in tools that are designed to be specifically used with VoIP troubleshooting. We'll elaborate on these later in this lesson. This software is very common in the IT world, and its use should not surprise anyone with network troubleshooting experience. However, caution should be taken when using Wireshark on a corporate network. Because of Wireshark's monitoring power, its use could potentially be viewed as a security threat. If you need to move forward with running a trace, make certain that the relevant IT parties are aware of your intentions. It's always easier to ask for permission than beg for forgiveness. As with any complex troubleshooting software, Wireshark's potential can only be reached when it's used correctly. Coincidentally, the most common misuse of Wireshark happens before the software is even opened. In order for information to be gathered correctly, the network itself needs to be configured to provide a successful trace. In this opening troubleshooting video, we'll discuss what this means in some detail. The majority of packets that leave a VoIP endpoint are intended to be delivered point-to-point. When these types of packets are sent using an Ethernet switch, it is expected that the switch will only send and receive packets to the ports that need to be directly involved in the exchange. This is a unicast exchange and allows other network devices to not be burdened with traffic that is not necessary. But this can cause a problem when placing a computer running Wireshark on the network for troubleshooting. The network itself must be configured to allow Wireshark to eavesdrop in on the unicast packet exchanges. This can be done by setting up a port mirror on a network switch. Port mirroring is a diagnostic feature available for use in most managed Ethernet switches. It allows a selected port on the switch to act as a monitor of other ports on the switch. A computer that is running Wireshark can be plugged into this monitor port, and it will receive a copy of all traffic that is sent and received to the source port. This animation expands on this concept further. Here's a Tessera VoIP endpoint that needs to be monitored. However, simply plugging a Wireshark computer in the network switch will not allow us to see any of the unicast traffic that leaves the VoIP card. An Ethernet switch's greatest strength is that it only delivers packets where they are needed. So as you can see, our monitoring computer is not receiving the required information. That is, until the switch is configured with the port mirror. In this case, the SVC2 connection on port 1 is commonly referred to as the source port, while port 2 is referred to as the destination port. Now when a packet is sent to or from the monitored device, you can see that the information is passed along to the monitoring computer. At this point, Wireshark will start to log these packets and troubleshooting can commence. Setting up a mirror port on an Ethernet switch is not typically a complicated or time-consuming process, so a request to the IT department to facilitate this setup shouldn't encounter any significant pushback. The IT admin will need to know which switch and port the VoIP endpoint is connected to, and will inform you which port will be set as the destination. Your Wireshark computer will need to be connected to that port. Every switch manufacturer has different mechanisms to set up port mirroring, which makes it impossible to define a standard on how this monitoring practice should be put into place. But in order to show the relative ease of the process, we will demonstrate the setup on a Netgear GS724T Ethernet switch. This switch was selected because at the time of this lesson's creation, it was being sold by Biamp Systems for use with Tessera AVB connections. This makes it a commonly used switch with our customers and an obvious choice for our example. However, the basic process will likely be very similar in other switch components. Here's the web interface for the Netgear switch. Port mirroring settings are normally found in the monitoring or diagnostic section of a switch configuration, sometimes found as a subset of the administration settings. In this switch, the monitoring tab is selected, followed by a click on the port mirroring header. Many switches, including this Netgear switch, will allow you to select multiple sources to a single destination. This allows you to monitor different devices in a single Wireshark session. In most cases, however, a single source is selected to reduce the complexity of the resultant trace. In the Netgear switch, I simply select the switch port that I'd like to monitor, and then define the port that will act as the destination. Once this setting is applied, the mirror is in place. It's worth noting that once a port is set up as a mirror, its use as a standard network port is removed. Port 2 on this switch can only be used as a monitor and will not act as an interface to the network. For this reason, the port mirror should be removed once troubleshooting is completed. It is sometimes typical that the switch containing the port mirror is not a static part of the installed Ethernet network. This method of network setup can be useful if you don't have access to setting up a mirror on the building network, but still need to put a trace into place. In this example, a temporary switch is placed between the endpoint and the installed network. This switch is then set up with a port mirror, and a Wireshark computer is used for troubleshooting. Once any issues are resolved, the VoIP endpoint is reconnected to the VoIP network and normal operation resumes. Remember, it's always a good idea to inform the IT department of your monitoring intentions before you simply connect up and run a trace. We have concentrated on the use of port mirroring to set up a network trace of an endpoint, because this is by far the most common procedure put into place. But there is another way. One could also make use of a device known as a network tap to provide the monitoring functionality. Port mirroring may encounter issues that can affect the reliability of the trace. In situations where there is a large amount of network traffic in place, lower quality switches may simply not be able to meet the demand placed upon them. You may even find that the priority given to the port mirror process is low compared to other switch functions. A switch will first provide the core network functions it is designed for, and then offer up support for diagnostic features. In either of these situations, you may find that not all of the packets on the network will be found in the trace after it's run. A network tap is a device that has been specifically designed to be used as a monitoring device. However, the specialized functionality is often reflected in the device's cost. Network taps are designed to be used in situations where network traffic is at a high volume, like the point where a local subnet uplinks to a router. VoIP troubleshooting normally entails the monitoring of a single device, so a tap may be a bit of an overkill. However, their use would result in a successful monitor. Network taps are simply inserted between the endpoint and the switch. At minimum, the tap will offer a port that can be used to supply copied packets to the monitoring computer. In this lesson, we looked at the steps that should be considered when VoIP troubleshooting must take place. This includes the basics of interacting with the VoIP administrator and referencing Biamp Cornerstone. We also introduced methods that can be used to set up the VoIP network to allow further troubleshooting via Wireshark.